Good day, everyone, especially my students. I welcome you to Lagos State E-Science Practical class. My team and I, Odusa Atolokwe Joseph, a Lagos State chemistry team, will be taking you through a three peculiar topic that you will need when you are writing your WASEC exam. The first one is the laboratory apparatus and the experimentation. And the second one is the rate of chemical reaction, which I'm promising you is going to be more practical oriented. And the last one will be identification of gas or gases and the anions. You remember we cannot do this by just talking, so we have to walk down to the lab and let's start doing experiments.
E-Science Practicals, achieving success in science subjects.
Hello, welcome to this very interesting chemistry experiment. My name is Lukman Savage, your chemistry teacher and an instructor. Our topic today is experiment to verify the effect of concentration of reactants on the rate of chemical reactions. Our learning objective, like I said earlier on, is to actually demonstrate and verify whether change in concentration of reactants actually affect the rate of chemical reactions or not. To carry out this experiment, we are going to look at these keywords from our previous lessons. Number one, chemical reactions. If I may ask you, what is a chemical reaction? Yes? A chemical reaction is a process in which one of these reactants, or what we call substances, is converted to another substance known as products after undergoing transformation. The second question from our previous lesson that I want to ask you is rate of chemical reaction. What is rate of chemical reaction? Yes, the rate of chemical reaction can simply be defined as the amount of reactants produced per unit time or products formed per unit time. And the third one that I'm going to ask you, my students, on rate of chemical reactions from our previous lessons is what are the factors that actually affect or influence the rate of chemical reactions. Okay, let's look at them together. Number one is the concentration of reactants. Number two is the temperature of the reacting mixture. Number three is the surface area of the reactants. Number four is catalyst. The addition of catalyst to a reaction can also influence the rate of chemical reactions. The next one is light, presence of light. And the last one is pressure, if one of the reactants is a gas. Having said this, let us now look at the experiment that we want to demonstrate here today. We want to actually look at how the concentration of reactants affect the rate of chemical reaction between dilute hydrochloric acid and sodium trioxo sulfur sulfate 4. When these two reactants combine together or react together, they give us products. The four products are sodium chloride, sulfur 4 oxide, sulfur, and water. Let us now use this experiment to verify how change in concentration of one of these reactants affect the rate of chemical reactions. What are the apparatus that we are going to use? Let us look at them. Number one is dilute hydrochloric acid. 1 molar solution of hydrochloric acid, and that is what I have in this beaker here. The second one is a solution of the sodium trioxo sulfur sulfate 4 solution. The fourth apparatus we are going to use are conical flasks. In this experiment, we are using 5 conical flasks that have been labeled as A1, A2, A3, A4, and A5. The next one we are going to look at is beakers. It is in the beaker that we are going to add our water of different volumes. These beakers are labeled. Here, I have a beaker that contains water. So the beakers are also 5, just as the conical flask are 5. The next apparatus we are going to use are the measuring cylinders. The next one are the test tubes. The test tubes are only used to hold the dilute hydrochloric acid, which is the second reactant. Do not forget that we have 2 reactants here, the hydrochloric acid and the sodium trioxosulfur sulfate 4 that I'm going to put in the conical flask. So the last one among our apparatus or reagents that we're going to use is a white paper and a black pen that we're going to mark as X. Having said that, let us now go into the experiment. So I have my sodium trioxosulfur sulfate 4 in this first conical flask. The volume here is 50 cubic cm. Of course, I've used my measuring cylinder to measure 50 cubic cm into the conical flask A1. In conical flask A2, I have 40 cubic cm of that same solution, that same reactant. The conical flask A3 contains 30 cubic cm of that same reactant. Conical number 4 contains 20 cubic cm of the solution or that reactant, while conical number 5 contains just 10 cubic cm. I am now going to use the water that I have in the beakers to dilute each of these contents that I have in the conical flask. Remember that I have 50 cubic cm here, so I'm going to dilute it with water of 20 cubic cm so that the volume, the total volume of the content here will now be 60. So that is the first thing I'm going to do. So this is 50 and I have 10 cubic cm of water. So I pour in my 10 cubic cm of water into 50 cubic cm of my sodium trioxosulfur sulfate 6, and I bring my white paper with my eggs. Then, of course, this is 5 cubic cm of my dilute acid, hydrochloric acid. Of course, my stopwatch. If you look at my stopwatch, the reaction has not started. So I'm going to pour this hydrochloric acid into it and now time it. The time taken for the eggs to disappear, I've started it. 1, 2, 3, 4, 5. Stop. I have 5 seconds. 5 seconds for the eggs to disappear here. That is for the first one. For the second one, let's go to the second one. Of course, let me take this away from here. So for the second one, I'm done with this. I've taken the time. It takes 5 seconds for that reaction to come to completion. So for the second one, that contains 40 cubic cm of our sulfite, I have going to pour in 20 cubic cm of my water to dilute it so that the content will now be 60 cubic cm. Remember, as I am diluting it, the concentration of the reactant here is decreasing. I have my 5 cubic cm of my acid here. So my stopwatch reads 0 now. So the moment I pour it inside, I will start my stopwatch. Okay? Let us watch. Okay, it starts. Okay? The cross is disappearing gradually. Stop. I have 10 seconds here. It takes 10 seconds for the X, that is the cross, the black cross on the white paper, to finally disappear. So that is the time taken for the reaction to occur. I'm going to the third one, where we have 30 cubic cm of heat. So that 30 cubic cm of heat, I'm adding 30 cubic cm of water to it. So let me put this one aside. This is my 30 cubic cm of water. I'm adding it to make it 60. Okay. Now, let me now pick my hydrochloric acid, dilute hydrochloric acid, 5 cubic cm. When you look at it very well, the volume of the dilute hydrochloric acid is constant. It is 5 cubic cm all through. While the volume of the sodium trioxosulfur sulfate 4 is actually decreasing by addition of water into it. Okay? The moment I pour this, then, okay, start. The reaction is taking place. The cross is gradually disappearing, but it has not finally disappeared. It is disappearing, disappearing. I can't see it again. Stop. I have 15 seconds there. So it takes 15 seconds for it to disappear. It takes 15 seconds for the reaction to actually come to completion. The next one is this, where I'm having just 20 cubic cm of my sulfite. Okay? Let me measure that so that you can see how it is being measured. 20 cubic cm of it. Okay, and I have 20 cubic cm of it, and that was how others were also measured. You can see this is 20 cubic cm. So I actually reserved this so that you can see how others were measured. So I'm pouring 20 cubic cm of my sulfite into the conical flask A4. So let me now add the water to it. The water I'm adding here is 40 cubic cm. So the content, the entire volume will now be 60 cubic cm. One thing you will notice is that the volume of the sulfite is gradually decreasing, while the water we are adding is increasing. As such, it means that the concentration of the sulfite is decreasing, but that of the hydrochloric acid remains constant. So let me pour the water here, 40 cubic cm of water into 20 cubic cm of the sulfite. Okay? Now, I have my 5 cubic cm of my dilute hydrochloric acid. And my stopwatch here, it is reading 0, 0. Okay? The moment I pour it there, I watch out for the time taken for the X, that is the cross, the black cross on the white paper, to actually disappear. I'm going to watch through or observe through the conical flask. When I pour it, I'm going to, okay, start. Okay, it is changing gradually. I can't see it again. Stop. 20 seconds. 20 seconds for the reaction in conical flask A4 to come to completion. So let's put that aside and now go to the fifth one, which is the last one. So I have 10 cubic cm of my sulfite here and 50 cubic cm of water here. So what I'm going to do now, let me pour the water there in the conical flask to dilute the sulfite. Okay? Now, I have my last portion of my acid here, 5 cubic cm of my HCl. This is my HCl. Let me measure 5 cubic cm of my HCl. Here is my conical flask. Let me rinse it. Okay. 5 cubic cm. So this is my dilute hydrochloric acid, 1 molar solution. So I want to measure 5 cubic cm of it, just as we had in other beakers. So I have 5 cubic cm of my hydrochloric acid here. So the hydrochloric acid, I'm going to pour it, the 5 cubic cm, into the content of the conical flask. And note my time, the time taken for the reaction to occur. You will agree with me that this is a very interesting chemistry experiment. So let's count, watch out. When I pour it in it, then I'm going to take the time. Start. The reaction has started. The cross, the black cross is gradually disappearing. It is disappearing, but I'm still seeing it. I can still see it. I can still see it. It is gradually disappearing. It has not disappeared completely. Stop. I have 25 seconds there. 25 seconds. With this, we have come to the end of the practical session. Now, let us now look at these values and tabulate them. From the table you are looking on the screen, what is your observation? I want you to look at the volume of the sodium trioxosulfur sulfate 4 solution. Remember, 50 cubic cm of it was the first one we used. We diluted with 10 cubic cm of water. 40 cubic cm of it in conical flask 2, diluted with water. Then 30 cubic cm, 20 cubic cm, and finally 10 cubic cm. And all these volumes of the sulfite were being diluted with more water. Now, I want you to look at that table, those values there that you are looking at on the screen, and the time that is written against each of those experiments to come to conclusion. What can you observe? What can you say about it? Now, you will discover from our conclusion that my own observation is that as the concentration of the reactant, that is the sodium trioxosulfur sulfate 4, is decreasing, the time taken for the reaction to take place and come to conclusion is increasing. When we're using 50 cubic cm of it, diluted with 10 cubic cm of it, it was just 5 seconds. As we're moving down, decreasing the concentration, the time taken for the reaction kept on increasing. Look at the first in the beaker A1. Look at the time, 5 seconds. Look at the volume of the last one, which is 10 cubic cm. Look at the time taken, 5 seconds for the reaction to come to completion. So from this, we can conclude that as the concentration of the reactant, sodium trioxosulfur sulfate 4, is decreasing, the time taken for the reaction to take place is increasing. Invariably, we can also say that as the concentration of the reactant is decreasing, the rate of chemical reaction is increasing. So thank you for watching, and God bless you.